Hello, students. Mr. Madison here, and I thought that I'd try a little something different in hopes that it would be more effective for you insofar as explaining to you how to do these problems. The problems that we're doing are the problems from your arc length practice assignment, and I have in front of me here the problems that I sent you to do. And so I'm going to make, let's call it a video key. So rather than just sending you a key with all the problems worked out, I'm going to give you an opportunity to watch me work the problems while I add commentary and explanation in hopes that you'll gain a better understanding of how to do these problems. So basically, I'm just going to work these problems for you. As I'm working them, I will explain to you what I'm doing. These problems are arc length problems. Problem number one, ask you to find the arc length of AB. AB goes from here to here. So this arc that we're trying to find the length of has a degree measure of 160. Our primary tool is our arc length formula, which I'll write right now just as a reminder. Arc length is equal to x degrees. Let me pause for a moment. This x degrees refers to the degree measure of the arc that you are trying to find the length of. So in this case, x would be 160. So I've got x over 360. Let me pause again. This value, x over 360, gives you the fractional part of the circumference that the arc is. Remember, arc length is always some fraction times the circumference, and the circumference would be 2 pi r. So I'm going to plug in here, and I'm going to have the arc length is equal to 160 over 360 times 2 times pi times the radius, which is given as 27. So now, really, all I have to do is my arithmetic, and I could use my calculator for that. I'm going to just go ahead and put pi here. And the reason I'm doing that is because I've been asked to find the arc length in terms of pi. So I'm not going to multiply by 3.14 or any other decimal approximation for pi. I'm just going to leave pi in the answer. So I have my calculator here. And what I'm going to do is I'm going to go into my calculator and I'm going to do this calculation. I'm going to do 160 times 2 times 27 divided by 360. Enter. And I'm coming up with 24. So my answer here to problem number one is 24 pi. And because the units here is inches, it would be 24 pi inches. So that's the distance from A to B. If you needed an approximation that just kind of made a little more sense to you, you'd go ahead and multiply 24 by pi, and it's going to be a little bit over 75 inches is what it would be from there to there. Let's go on to problem number two. Problem number two is very similar to problem number one. We're trying to find the length of arc RS. It goes from R to S this way. That's a minor arc. And the degree measure of that arc would be 108. So I'm just going to utilize my arc length formula. Arc length would equal the degree measure of the arc, which would be 108 over 360 times 2 times pi times the radius, which is given as 25 inches. I'm going to go ahead and put pi down because I'm finding my answer in terms of pi. Picking up my calculator, and I'm doing this calculation. I'm doing 108 times 2 times 25, and then dividing all that by 360. 108 times 2 times 25 divided by 360, and I'm coming up with 15. So the arc length here would be 15 pi inches. In problem number 3, we're asked to find the arc length of arc TUN. Now, TUN starts here at T and goes all the way around the long way. TUN is a major arc. Now look, this is 90. N to T measures 90 degrees. So N all the way around to T the other way would be 270. So when I write my arc length formula out, what I need to do is above that 360, I need to put the degree measure of the arc I'm trying to find, which would be TUN, which would be 270 degrees. The error that is most often made on a problem like this is for someone to put the 90 there. You would put 90 if you're trying to find the arc length of NT, but we're not. We're trying to find the arc length of the major arc from N to T. Times 2 times pi times the radius, which is given as 14. So my arc length here is going to be, I'm going to go ahead and put pi down. My calculation is going to be 270 times 2 times 14 divided by 360. And that's coming up to be 21 or 21 pi inches. Problem number 4 is similar. We're trying to find the arc length of PCK, which is this major arc that goes all the way around. This angle right here is 45, so this arc would be 45. But the major arc would be 360 minus 45. So when I plug into my arc length formula here, I'm going to have 315 in my numerator over 360 times 2 times pi times the radius, which is given as 22. Time to go to the calculator here. I'm going to get my answer in terms of pi. In my calculator, I am putting 315 times 2 times 22, then dividing that by 360. And I'm coming up with 38.5 times pi. You can also express that if you want as a fraction. Let's see, that would be 38 and a half would be, let's see, 77 halves pi. Let me check that on my calculator. 77 divided by 2. Yep, 38.5. So either one of those would be an acceptable answer. Let's go on to number 5. Number 5, we're trying to find the arc length of WH. That's this minor arc here. And this arc WH has a degree measure the same as the central angle that intercepts it, which would be 150. So when I plug into my arc length formula, I'm going to put 150 on top. Times 2 times pi times the radius is 18. Time to go to the calculator. Put the pi down. Excuse me, folks. Now, in my calculator, I'm going to do 150 times 2 times 18 and then divide by 360. And I'm coming up with 15, and it would be times pi, and the units would be inches. All right. Here we're trying to find the arc length of SN, which would be this minor arc right here that has a degree measure the same as its central angle, which would be 40 degrees. So I'm going to plug into my formula, and I would have 40 over 360 times 2 times pi times the radius, which is 4.5. If you want to write down 4.5, that would be fine. If you want to put down 9/2, that would be fine. Because we're using a calculator, it doesn't really matter. We're going to have pi in our answer. So I'm going to do 40 times 2 times 4.5. Then divide that by 360. And I'm coming up with 1. Let me do a check on that. 40 times 2 times 4.5, and then I'm dividing all that by 360, and I'm coming up with 1. So you could put the 1 there if you want. You're good to go if you don't, and that would be your answer. Let's go on to this problem. We're trying to find, in number 7, the arc length of KC. And I take that back. We know the arc length of KC. From K to C is 13 pi inches. What we don't know is R. So here's what we're going to do. I'm going to write the arc length formula, plugging in what we do know, and then we're going to solve for R. So we already know the arc length. So instead of writing A period, L period, I'm going to write 13 pi, because that's the arc length, and that has to equal the degree measure of the arc, which is 90, divided by 360, times 2 times pi, but all I can do is put down R, because I don't know R. Now my job is to use my algebra skills to isolate this variable R. First thing you need to notice is that you have a pi on the right and a pi on the left. So those pi's cancel out. That's what happens if you would divide both sides of your equation by pi. Now to isolate this R, I need to get rid of this 2, and I need to get rid of the fraction 90 over 360. So watch what I'm going to do here. I'm going to put 13 down, because that's what I have on the left-hand side. Then I'm going to multiply by 1/2, because if I multiply by 1/2, I'd get rid of that 2. Then I'm going to multiply by the reciprocal of 90 over 360, which would be 360 over 90. And that would give me R. So when I go to my calculator, I'm going to do 13 times 1 times 360, and then I need to divide by 2, and I need to divide by 90. So I'll talk myself through it here. I'm going to do 13 times 360. Now I'm going to go ahead on my calculator, and I'm going to do this calculation in a couple steps. So when I do 13 times 360, I'm going to go ahead and hit enter. Then I know that I need to divide by 2, and I need to divide by 90. So if I wanted to, I could just divide by 180, but I'm just going to do it in steps, and I'm going to go divided by 2, enter, divided by 90, enter. And I'm coming up with 26. And because the arc length is given in inches here, then I know that that would be 26 inches from my radius. Now in problem number 8, we're trying to figure out the degree measure of that angle there. So let's plug into our formula. Arc length of JV, that's this arc here, is 11 pi. So I could say the arc length, which is 11 pi, has to equal x over 360. I don't know what that degree measure is. That's what I'm solving for. Times 2 times pi times the radius, which is 33. So at this point, I basically just have an equation. I'm going to use my algebra to isolate x. Now the pi's cancel, and I have to get this x all by itself. So here's what I'm going to do. I'm going to write down the 11 over here. Now anything over here that's being multiplied by the x, which would be the 2 and the 33, I need to divide by. And anything over here that's being divided into the x, which would be the 360, I need to multiply by. So I'm going to go 11 times 1/2, that would get rid of that 2, times 1 over 33, that would get rid of that 33, and then I have to multiply by 360. That would get rid of the 360 in the denominator there. And that's all going to equal x. So in my calculator, and again, I like to do this in steps, so I'll just verbalize what I'm doing. I'm doing 11 times 360. Then I hit enter. Then I say divided by 2, enter, divided by 33, enter. And I'm coming up with 60 degrees as my value for x. Okay, onward we go. Up here, problem number 9. What do we know? We know that the arc length of BMW is 20 pi. So from B all the way around to W is 20 pi inches. And then we have to find 1, 2, 3, 4 values we're being asked to find. Now let's think about this for a second. Excuse me once again. This 60 degrees right here tells you that the arc length from B to W here would be 60 360ths of the circumference. 60 out of 360 would be from B to W. That, by the way, is 1/6. Now, I want you to think about it. If from B to W is 1/6, then from B all the way around to W has to be 5/6 of the circle. So here's what I know. I know that the arc length of BMW is 20 pi. That has to equal 5/6 of the circumference. Now, I could figure out what the circumference is here by multiplying both sides of this equation by this reciprocal, 6/5. So when I go to my calculator, I'm going to do 6 times 20 divided by 5. And 6 times 20 divided by 5 would be 24 pi. So that's the circumference. Now, do you remember I gave you this little problem-solving tool? Kind of a table. And I said to you at that time, the point is that if you know any one of these three, you can get the other two. So we know right now that the circumference is 24 pi. The diameter then would have to be 24. And the radius would have to be half of that, which is 12. The only thing we have left to find is B to W. Well, we know that B to W is 1/6 of the circumference. So if the circumference is 24 pi, 1/6 of 24 pi is going to be 4 pi. So we got all our answers. Let's review what we did in this problem. We were told the arc length from B all the way around to W. But we knew that because this was 60 degrees here, that had to be 300 degrees there. That big major arc had to be 300 degrees. And if you form the ratio 300 out of 360, you end up with 5/6. So that arc length, BMW, had to be 5/6 of the circumference. So I just put the 20 pi equal to 5/6 times the circumference. I isolated the circumference by multiplying both sides by 6/5, and we found the circumference first. It turned out to be 24 pi, which meant the diameter would be 24, because the circumference is always a diameter times pi. So the diameter would be 24, and then the radius would be 12. And now we know the circumference is 24 pi. This arc from B to W is 1/6, and 1/6 of 24 pi has to be 4 pi. All right, onward we go. Looks like this next problem is very similar. Arc length ELG is 104 pi. So from E all the way around to G is 104 pi. Now this 72-degree angle tells you that this arc E to G is also 72 degrees. Now 72 out of 360 is 1/5. So E to G would be 1/5 of the circumference. So it stands to reason then that from E all the way around to G would have to be 4/5 of the circumference. So here's what I know. 104 pi, which is the distance from E all the way around to G, is 4/5 of the circumference. 4/5 of the circumference. Now, just like in the last problem, I'm going to multiply by the reciprocal. So to figure out what C is, I'm just going to multiply 5/4 times 104. That would be, what, 26 there. So I think we're going to end up with 130 pi is equal to the circumference. Now, if I make my little table, radius, diameter, circumference, if the circumference is 130 pi, then the radius, the diameter would be 130, and the radius would be half of that, which would be 65. So I've got 130 here. I've got 65 here. And the only thing I got to find is from E to G. Well, E to G, remember, is 1/5 of the circumference. So to find EG, I'm just going to take 1/5 and multiply by the circumference, which is 130 pi. And 5 goes into 130 26 times, so it's going to be 26 pi would be the answer. All right, let's look at number 11. We know that the arc length of LSQ, that would be all the way around, the major arc here, is 25 pi. Okay, 25 pi all the way around. We know that the radius is 15, and we're trying to find the degree measure of this angle right here. Okay, well, let's think about this. I know that arc length is equal to the degree measure of the arc divided by 360 times 2 times pi times r. Remember, this number right here has to be the degree measure of the arc that you're trying to find the arc length of. So what you need to understand is that in this problem, this arc from Q all the way around to L does not have a degree measure of x. It has a degree measure of 360 minus x. So when I plug into my formula here, for the arc length, I'm going to have 25 pi but the number I put on top here has to be the number of degrees for that arc that has a length of 25 pi. And that expression that I'm going to put there has to be 360 minus x. Once again, if this is x from here to here, then the rest of the way has to be 360 minus x times 2 times pi times the radius, which is 15. Then I need to solve this thing. So the pi's cancel here. And here's what I'm going to do. I'm going to take this 25 right here, and I'm going to multiply by 1/2. That would get rid of that 2. And I'm going to multiply by 1/15. That would get rid of that 15. And I'm going to multiply by 360. That would get rid of this 360. That would leave me on the right-hand side with just this expression, 360 minus x. So I'm going to do this calculation in my calculator right now. So I'm going to go to my calculator, and I'm doing 25 times 360. And I go ahead and I do this in a couple steps. So I'm going to hit enter. Then I'm going to say divided by 2, enter, divided by 15, enter. And I'm coming up with 300 is equal to 360 minus x. Now at this point, let's just use some common sense. What would x have to be so that if you subtract it from 360, you get 300? And it's obvious that it's going to be 60 degrees is our answer. X is 60. That's our answer. So let's rerun this problem very quickly. All we did was we wrote our arc length formula, and then we substituted into the formula the information we have. The one little twist on this problem is that when we put our degree measure for our arc in here, we had to put it in as 360 minus x. This x right here is not the degree measure of this major arc. It's the degree measure of the minor arc. So you'd have to subtract the x from 360 to get that degree measure of that major arc. And then we just use a little algebra to solve for x. Let's do problem number 12. What do we know in problem number 12? The arc length of HRT, that's from here to here, is 36 pi inches. We're trying to find this angle right here. So let's again plug into our arc length formula. We've got 36 pi for arc length equals, now remember, this value that you're going to put right here in the numerator has to be the degree measure of the arc length of the arc that has a length of 36 pi. So if this is x here, then from h all the way around to t has to be 360 minus x times 2 times pi times the radius, which is given as 30. So we're going to go through the algebra now. The pi's cancel. I'm going to write this 36 down. To get rid of this 2, I'm going to multiply by 1/2. To get rid of this 30, I'm going to multiply by 1/30. To get rid of the 360 in the denominator over here, I'm going to multiply by 360. That would leave me with just 360 minus x over here. Going to the calculator now. I'm doing 36 times 360. Enter. Divided by 2. Enter. Divided by 30. Enter. And I'm coming up with 216 is equal to 360 minus x. Now what I'll do is I'll just switch places here between this x and this 216. X would have to equal 360 minus 216. Let's not mess it up at the end. Let's do our calculator. Use our calculator. 360 minus 216 happens to be 144. So this angle right here is 144 degrees. This degree measure from H all the way around here would be 216. So there you have it. Basically, to find the answers to all 12 of these problems, I'm going back to my arc length formula, plugging in the values I'm given, and then using a little algebra to isolate what I'm looking for. So I hope this video key was helpful to you. There'll be another posting for 12 more problems for you to do. I think that probably everybody needs a little bit more reinforcement on this. So thanks for listening, folks, and I really, really hope this was helpful to you. Y'all take care. Thanks for listening. Bye.